Hello. Today we are going to discuss about the electrolysis of acidified copper sulfate solution using copper electrode. Okay, just before discussing about this topic, I have to inform you some important things. This year, you have two board exams. You have to write two board exams. Up to last year, there was only one board exam in the last, means in the month of March. But this year, you have to write two board exams, means even in CBSE also two board exams would be there. For first board exam would be in the month of, most probably it would be in the last of October or in November. So for the first this one, for the first board exam, in chemistry you have to study periodic properties and variation of properties, that first chapter. Then second chapter, chemical bonding. Then third chapter, study of acid, base and salt. Fourth one is analytical chemistry. Fifth one is mole concept and stoichiometry. Then sixth one, electrolysis. So first two chapters we finished completely. Then chapter 6, which we are studying now. Then chapter 4 and 5, very small chapters only, that we'll be able to finish within 3-4 videos. Then chapter 3, as soon as this chapter finish, we'll go to the chapter 3. Okay, so these are the things which you have to study for the first semester exam. That's I'll send the syllabus along with this video. Okay, the for every subject two board exams would be there. Okay, anyway, come back to our portion. Electrolysis of acidified copper sulfate solution using copper electrode. Then before also I already told you to study the active electrodes and inactive electrodes. Inactive electrode means we don't need to worry, as usual we will be able to write. But in here you can see that we are using copper as the electrode. You can see here it is. Copper means is it active or inactive? Yeah, we know that copper is an active electrode. So the total reaction, how to write the reaction would be different. So we are going to discuss those things. Okay, so first one, electrolysis of acidified copper sulfate solution. So which means that acidified copper sulfate means there are the electrolyte which is made with three solutions. The electrolyte which is made with three solutions. First one is the acidified, means sulfuric acid would be there, H2SO4. Then second one is the copper sulfate, CuSO4. Second one, copper sulfate. Then third one is the water. So three electrolytes are there. So just check the diagram. Sorry. So when we are drawing, then electrolyte which is made up of copper sulfate plus H2SO4 plus H2O. Then both the electrodes are made with the copper. So we can take this as the cathode and anode. Both the cathode and anode, both are made with the copper. Copper is an active metal. So as usual, I am going to erase it. So as usual, when we pass the electricity through the electricity through the electrolyte, the sulfuric acid will dissociate as H2SO4 will dissociate as H2O H2 sorry sorry sulfuric acid will dissociate as H plus sulfuric acid will dissociate as H plus and SO4 2 minus. Then copper sulfate will dissociate as Cu2 plus and SO4 2 minus. Then when it comes to water, H2O will dissociate as H plus and OH minus. So you can see here. So there are two kinds of cations are there. You can see here two cations, H plus and Cu2 plus, and there are two types of anions, sulfate anions and OH anions. You can see here. So as usual, the cations, positively charged cations will move to the cathode. That's we know that the positively charged cations will goes to the cathode and will gain electrons from the negatively charged cathode and will become neutral. So in here two cations are there, hydrogen H plus and Cu2 plus. Among these two, which one will move to the cathode? Yeah, we can see here that the Cu2 plus is in the bottom part in the electrochemical series. So Cu2 plus will move to the cathode and it will gain 2 electron and will become neutral. Okay. Then at anode, this is the most important part. We know that in here we are using copper as the electrode. Copper means it is a active metal. Then what will happen? Among these two, sulfate radical and OH radical, hydroxide radical and sulfate radical, which one will move to anode? Obviously we know that it is hydroxide radical, but will it be like that? The answer is no. From these two, no one will move to the anode, because if it is a inactive metal means hydroxide radical can move, but in here the electrode is active. So from these two, which one will go? No one. So in that case means when we use a inactive element, the anode itself will dissociate. Means suppose if the anode which is made with copper only, we know that Cu will lose. The anode is made with copper. That copper will lose 2 electrons. The copper will lose 2 electrons and will become Cu2 plus. You can see. Then this Cu2 plus will goes to the electrode. The Cu2 plus will move to the Cu2 plus produced at the anode will move to the electrolyte. From there it will goes to the cathode. This is the reaction which is taking place. Understand? When we use the active metal, the active metal itself will lose electron and will become cation, and it will move to electrolyte. From the electrolyte it will goes to cathode. In cathode means the cathode will gain cation will gain 2 electrons from the cathode and will become neutral, and this copper will deposit at the cathode. Cathode is also made with the copper only. Then anode. From anode, the copper is moving to electrolyte. From there, it is moving to cathode. As a result, with our naked eyes, we'll be able to see that anode will become thin. Why it is becoming thin? Because the electrons are, the metallic part is moving to the electrolyte, and due to the deposition of the copper, the cathode will become thick. Clear? So what is the result? If you use a active element, the cathode will become thick and anode will become thin. This part you have to study it thoroughly. Okay, don't get confused with the active element, active electrodes and inactive electrodes. I'll send the notes along with this video. Watch it, study it. Okay, thank you.